Hello guys, welcome back to the video series. We're going to be going over some practice problems, so congrats for making it through the first and second video series. This is a sample FRQ taken from the 2023 AP exam. You can find all of the past AP Chem exam FRQs on their website. But let's get started. So HCl is a molecular gas as a pure substance, but acts as an acid in aqueous solution. So these are just like, this is just the first part of the problem, so we're only going to be focusing on the gas aspect, don't worry. Okay, A. A sample of HCl gas is stored in a rigid 6-liter container at 7.45 atm and 296 Kelvin. 1. Calculate the number of moles of HCl in the container. So here we are given a ton of other values and we're trying to calculate a specific value and we're not looking at a change. So we know that we're using the ideal gas law. The other point that I want to address is how to approach this problem for the AP exam specifically. So you want to make sure that you write out some version of the formula. So you can say like PV equals nRT, or like in that case, N is equal to PV over RT. And then make sure that afterwards you write it out such that they can tell what values you plugged in for which of the representative variables. And note that on the AP exam formula sheet, they will give you the value of R, and they, for liters atmospheres, they give it to 0.08206, so 4 sig figs. So let's say N is equal to PV equals PV over N over RT. So we can say that N is equal to 7.45 atm times 6.00 liters, all over R. So this is 0.08206 liters atmospheres over mole Kelvin, and then times 296 Kelvin. Note that we didn't have to convert everything because they very nicely gave us the units and things that we know. So now you just use your calculator. 7.45 times 6 divided by 0.08206, and then divided by 296. And then finally, you want to pay attention to significant figures. So here, even though 0.08206 is to 4 sig figs, the smallest amount of sig figs that we get for everything else is 3. So I'll round our answer to 3 sig figs and get 1.84 moles. So you don't worry about like a super long explanation, but just as long as you get those like 3 points, formula, plug your values into the formula, and then a correctly rounded answer, you'll be perfect. So let's try for the second problem. The rigid 6-liter container of HCl is cooled to a temperature of 271 Kelvin. Calculate the new pressure in atm of the HCl. Okay, well, now we're looking at a change, right? So we're not going to be using the ideal gas law. We're going to be using one of the other laws that we looked at. And currently, we're working with cooling, and it wants us to find the new pressure. So it might mislead us by like mentioning the volume again, but we are just working with pressure and temperature, right? And we already know what the original pressure was. And what the original temperature was, and we know what the final temperature is. So we should be able to calculate the new pressure. So this is Gay-Lussac's, if y'all remember. So we can say P1 over T1 equals P2 over T2. Or if you want, since we're calculating for the new pressure, you can just say P2 is equal to P1 times T2 over T1. And then plug in our values, right? So what was our original pressure? 7.45 atm. And what was our final temperature? 271 Kelvin. And then that's all over our original temperature of 296, 296 Kelvin. Again, calculator, 7.45 times 271 divided by 296. When we round to 3 sig figs again, we will get 6.82 atm. So these are the answers we got. Let me clear the board. Okay. And I included the scoring commentary from the AP website. So along with the past FRQs, they'll give you like sample responses and exactly what they're looking for. So this is the rubric for this question. And as you can see, we got the correct answers. And they do provide like what they're looking for, like formula-wise. You don't need to worry like if you just kind of like wrote out stuff differently, just as long as you have like the same general framework. Again, formula, plug in formula, answer to correct sig figs. Like as you can see, this student, like it wasn't exactly what they have here, but like for part I, but it was pretty similar and they got the correct answer, so they got full credit. I hope this is helpful and I'll see you for the third video series.